Our final presenter will be talking about a topic that I personally am very familiar with and ask the question, are you well architected? I'd like to introduce Nicholas Sanchez, COO at DinoCloud. Nicholas co-founded DinoCloud 4 years ago with the idea of creating a company that becomes a technological partner of its customers in everything related to cloud strategy. Nicholas?
Hey, John, thank you for the introduction. I'm trying to show my welcome here.
Yeah, not a problem.
Okay,
There it
there it is.
goes.
There
Awesome,
it is.
Nicholas. The floor is yours.
Thank you very much. Thank you very much. Hello, everyone. A pleasure to be here today. I'm going to be the last presenter, and I am going to be talking about what John said, the well-architected program and the experience as a partner. This question, are you well-architected, is the question that AWS tells you have to ask. First question you have to ask to a customer, are you well-architected? We're going to go through a little bit of what the program looks like, what it implies, and then we're going to talk about, in our experience as a consulting partner, making well-architected reviews, what are the more common errors or problems that we see in our customers' architecture, and what small steps you can take to improve your architecture, make it more solid, and make it more efficient. Okay. A little bit about me, okay, introduction, and enough about me with the introduction, but this is me. You can reach out with any questions if you want to have a word at my email, or you can follow me on Twitter there. I'm not very active, but I thought it would be good to share it with you. So let's get it started. So first of all, why am I talking about why am I asking, are you well architected? Well, we as consulting partners, we have the option to enroll in what is called the AWS well-architected program, which is a program where AWS authorizes qualified partners to perform reviews of architectures, particularly on AWS, but we're going to talk about a little bit more about that later. And the foundation of the program is actually the well-architected framework, which many of you probably already heard about. So the well-architected framework is this set of good practices that AWS put together with the grounds on, I think, over 12 years of thriving experience on small and large enterprise customers building application and building architectures on the platform. And so AWS took all that and put together this set of good practices in the form of pillars, which is going to be our main thread in this presentation, design principles on those pillars, and a set of questions that you can ask yourself or ask your customers to see or to assess if the architecture is following the best practices or is well architected. So what is the goal of the well-architected framework, among other things? First of all, to raise awareness on best practices on architecture. It addresses critical areas that are often neglected when building applications, maybe because you're focusing on your business, on providing value, or basically earning money. And it provides a consistent approach to evaluating architectures. Even though it's built by AWS, you can use this framework to assess any architecture in virtually any platform. So let's talk a little bit about pillars before we dive into what each one of them means and what do they look like regarding issues and what actions can we take to improve each one of them. So these are the 5 pillars of the well-architected frameworks and the base of the well-architected program reviews. When we as consulting partners go ahead and review architectures on our customers, we take these 5 pillars as guidance to start making questions and assess the different aspects of the architecture. The program assumes that any aspect of your architecture can be characterized in one of these pillars. So we have operational excellence, we have security, we have reliability, performance, and cost optimizations. A fun fact is that first there were only 4 of them, that are security, reliability, performance, and cost optimizations. But later, because of the different aspects that were aboard by the framework, they added the operational excellence pillar. So let's talk about pillars. What I'm going to do now, we're going to go pillar by pillar, see what it implies from the well-architected perspective. And I'm going to tell you a little bit about what small actions can you take today, or can you compare with what you're doing today, so you can go ahead and make them and have a slightly better or a lot better architecture. Okay, so first of all, we're going to start talking about operational excellence, okay? Which, from the well-architected perspective, it implies the capability of executing and monitoring systems, adding business value and perspective by improving all the support processor and procedures. Basically, the process of prepare, operate, and evolve. Basically, not only about your workload, but how do you operate your workload, and what tools, what set of technology, what processes do you have as satellites of your main workload? People, processes, and technology. So let's talk about a little bit on operational excellence. First of all, provide visibility. Basically, what we want to do here is to start making your workload not only production-wise and functional, but also visible, and give you everything, all the information you need to know to operate it. The 3 bullet points that I pointed out here was, first of all, define metrics to know what your baseline is. What does a production workload looks like to you? What is the size of it? What is the traffic on it? What does it look like on the different times of the day? So you really know when you are at a point, when you're underused, when you are when in the verge of facing a problem regarding metrics. And in that order, don't wait for a support ticket to know that something is wrong with your workload. Create alerts that really add value and let you know that something might be going wrong. I'm not talking about a sophisticated system. I'm talking about if you have your mail, if you have your base metrics defined, you can create some alerts in AWS to let you know that some metric is above the threshold or below the threshold, depending on the metric, to let you know that something might be going wrong, and prevent basically downtime or a poor experience to your customers or the customers of your application. Okay. And also about visibility, it's not a black box. Use dashboards. There's a lot of tools provide visibility to logs, to metrics through dashboards. You can use CloudWatch and really, and in a few steps, create dashboards for metrics on your resources. Another thing, regarding operational excellence, you can automate everything you can. You can, as a first thing, deliver faster. You can automate everything you can. If you're deploying an application, you can automate everything related to non-prod deployment. So you can deliver faster for testing, for pre-prod, for load testing, and you can provide product value easier and faster. Recover seamlessly. Plan a rollback strategy. If something goes wrong, have automated as much as automated as you can get to a rollback strategy, so your application, if it notices that something is wrong, goes back to a stable state or a previous version. And also, you can, from the operational excellence perspective, you can create things to manage your workload more easily by automating some simple responses to recurring events, like auto-scaling, like security breaches, like security root rules, or simple events that may affect from any perspective to your workload. You can, through CloudWatch, through Lambda, you can automate management responses that will take off the manual load of having to constantly be looking at your workload. Or if you may, you can call Logs.io, and I'm sure they're going to be able to give you a hand on this pillar. Okay, let's move on. Let's move on to security. This is a wider pillar. Okay. Obviously, we can define it lots of ways, but we are talking about the security of the workload in many aspects: protecting information, protecting the system, traffic, data, and everything in between, without affecting or impacting performance or user experience. Let's talk about a little bit on what is the usual, on what can we do to make our security pillar stronger on our architecture. First of all, who can access what? Okay, let's talk about what can we do to manage our users on permissions and access to the platform better. First of all, when you create IAM users, you can have a better management of permissions if you manage them through groups and assign policies to groups. So you don't have users with specific policies attached, and you can manage better the different roles that are interacting with the AWS console. I think that we see a lot here is that, and that this is why I put it this way, IAM users are not headless. If you are using access keys and secret keys in your application, in your deployments, in your code, you can do better. You can use roles in AWS to provide the proper access and credentials to your platform services or and the different nodes of your architecture. Ideally, you're not creating users for an application to access S3. You can do that to a role and make it more secure and leave the credential providing to AWS. Your only concern would be to build the application. Of course, this all goes away when you need to deploy from, I don't know, a Bitbucket pipeline, and you can assign a role to that. So you need to create a user. But ideally, when you're deploying inside AWS, the best practice is to use roles. And this is a very important thing that I want to think that any of you here in this are doing. But the AWS console login does not require an email. What do I say this? Because we have run into a fair amount of customers managing AWS through the console with the root account, and the root account is not meant to manage AWS. It's only meant for the creation of the account, and it should be MFA enabled and locked away for eternity, or when required, which should be very, very often. Use EM users. Don't use the root account to access the AWS console. Okay, moving on from identity, let's talk about a little bit about data. Okay, Jeremy is going to be pissed at me because he talked about encrypt what needs to be encrypted. It's really easy in AWS to have your data stores encrypted, at least with a base configuration, going from EVS to snapshots, S3, and whatever your data store is. It's really simple to add an extra layer of security by encrypting all of these services. And also, snapshot whatever you can. Take snapshots for whatever you're storing data, so you also make sure that not only they're encrypted, but they have a backup in the case anything happens. Regarding data in transit, simple things. First of all, take advantage of the Amazon Certificate Manager. You can use that to provide seamlessly certificates to all your services, to all your to the different nodes of your platform. And a very important thing is to put private what needs to be private. It's really we've run a lot into architectures that deploy some components in the public subnets. That carries many problems, but among them, if you put everything in private, you add another extra layer of security for your services to communicate between each other without having to worry that they are exposed to the internet. Okay. Okay, let's move on. Or if you may, you can call DinoCloud, and I'm sure they can give you a hand on this pillar. Let's talk reliability. From a well-architected perspective, we talk reliability on the capabilities of a system of recovering from failures at an infrastructure and or an application level, and to current release resources dynamically to match the demand and not be topped of resources or also under resources, which will impact mainly in costs. So regarding reliability, let's talk about a little bit on what small steps can we take to make sure that our architecture and our operations are more reliable. First of all, try your mechanisms. What do I mean by try your mechanisms? First of all, I'm sure lots of you managing AWS's workloads, backup, whatever aspects of your architecture you think needs to be, backed. But have you tried recovering the data? Have you tried recovering an EVS snapshot? Have you tried recovering the daily RDS snapshot that you're taking? Try recovering to make sure that your strategy is not only about backing up, but also it works when in the case of a disaster, in the case of need. Same goes to rollbacking. In operational excellence, remember we talked about have a rollback strategy that helps automated, that helps your application be resilient in the case of a failed deployment or something like that. Test it. Don't settle for a rollback strategy or for a configuration you already put. Test a rollback so you can actually see that the strategy works. That it's a really, really good way to make sure that the measurements that you already take on your architecture do actually work. Okay, following. Regarding reliability, we talk a lot in AWS architecture of high availability and elastic resources, on-demand resources. And this is very important. As long as your platform, as long as your application allows you to use elastic architecture, auto-scale whatever you can. If you have containers, auto-scale in ECS, auto-scale in Kubernetes. In EC2, you can. EC2 is I think the base service where you can apply this concept. If your application is stateless, take advantage of the auto-scaling metrics, the auto-scaling policies. And auto-scale whatever you can so you can match demand through traffic and provide resources just as needed, and obviously decommission resources when you're not using them. Load test all you can so you can have actually proper metrics on how will you auto-scale. It's not only about I want to auto-scale when my CPU is over 70% for I don't know 3 minutes. Load test whatever you can so you can have those metrics as more refined as possible so you actually know and prevent how will your architecture scale when demand increases, for example. And also, well, this is a little far-fetched or stretch, use as many IC as you can. You know, as when AWS says that your architecture or your platform, its platform is high available, it requires for you to deploy your application in at least 2 availability zones within a region. This in the paper gives you already high availability, but it's a great practice to span in if your application is big enough or you see it feasible to use to span it in 2 or 3 availability zones so you can make sure that your application is resilient in the case of an availability zone failure. Later on reliability, the thing and in everything I've been talking about is to plan for disaster. You can take small steps in your AWS console to be aware and to plan for disaster on small metrics that you can be taking. First of all, be aware of your IP availability. I'm sure you already planned your networking structure, your VPC, your list of net layers, what's going to be public, what's going to be private, what's going to be your CIDR, but be aware of the available IPs to be allocated at all times. If you have actually an elastic architecture, you know that when the demand decreases, you can have resources allocating new and new elastic interfaces. So it's a good practice to monitor. If you're going to be able, from a networking perspective, to allocate the resources that you need from the networking perspective. Another simple thing to do, track AWS service limits. You might not be aware, but there are lots of soft limits in your AWS console regarding the different resources. One of the most common one we run into is, for example, elastic IPs. You can't allocate a new elastic IP when you reach, I think, 5. There are lots of service limits that AWS has put there for your safety in the case your account gets vulnerable for some reason, or you have an intruder accessing your AWS's resources, so they can't deploy or they can spin up more resources than those limits. But if you're actually scaling elastically, you might run into those limits. So it's a good practice if you're using lots of auto scaling services to keep track of the service limits, so you know that you're not, how would you say, you're not shooting yourself in the foot by having an elastic architecture, but not being aware of that AWS will top you at some point. And if you have done all the things before, you might be able to define an RTO and RPO. For those of you who doesn't know it, RTO stands for recovery time objective, and RPO for recovery point objective. That basically goes for, in the case of a disaster, how much time can you be out, and regarding data, how much long in data can you lose. These are basic concepts for a disaster recovery strategy. But if you're already taking metrics on your application, and you maybe have an SLA you have to live up to with your customers, it's good to have an RTO and RPO that will define, for example, how much often will you take a snapshot, or if you're on auto scaling, does auto scaling instance spin up time match my desired or my proposed RTO? Define this kind of matches will help you decide if you're also using the proper services, or you need to re-architect some parts of your platform. Okay, moving on. Regarding reliability, probably AWS will be able to help you out with backups. So you can give them a call if you need help in that pillar. Let's talk about performance. Performance, well, it's a simple concept. It's one of the pillars of the well-architected framework, and basically it means it's all about keeping resources effective and efficient, going from the decision of the resources that we choose to how they behave in demand, right? The example we always give in this is serverless is really good, but if you're going to be handling millions and millions and millions of transactions, there can be a point where it will be more efficient to deploy in EC2, because the cost goes up on what was expected. So performance, keeping it simple, define and measure KPIs. KPI stands for key performance indicators. It's all about metrics. I've been talking a lot about that, and it's really good to start knowing and measuring your workload or workloads, and defining KPIs for each one of them, or for your business at least, and making sure your architecture can live up to those KPIs is a really, really good decision. And it doesn't take a whole assessment to define that. You know your workload and your business better than anyone, and you can know what are the key performance indicators, the basic ones that you can define and you can measure to make sure your workload is performing as expected. Measure application performance. There's lots of platforms you can use for that. Install an APM agent in your servers and start measuring that. Just to gain visibility on the tracing and the performance between your microservices. And another important thing is give it a thought and give it some time to select the best performing type of resources. It's really common when we get on architectures that are mainly on EC2 to find out that everything is T2, T3, M4, M5 using general purpose type of instances. That is fine. That is going to work fine. But many of the times when we ask why do you use that, the reason is, it was, or maybe it was a default. Maybe it's what looked like better. There are lots and lots and lots of variety of instance times regarding EC2 that will help you choose the proper type of resources that you need depending on what kind of workloads are you running. It's really important to give it a small thought to know if you're actually using the resources that you need to be using, or you can actually do better and perform best with maybe less resources, maybe lower costs. Okay, and last but not least, from the hand of our friends Cloud Checker, we're going to talk about cost optimization. This is the fifth pillar. And basically, when we talk about cost optimization, we take a look at everything that can be removed, everything that is unnecessary, or everything that can be improved from an architecture perspective that impacts in cost. It's about avoiding and removing unnecessary costs, whatever that implies, and or sub-optimized resources in your AWS architecture. Okay, let's talk about what can you do right now to make your cost strategy at least more efficient and make better decisions. First of all, it's really important to be aware. The billing dashboard is really cool. You can see all services, through services, what you're spending, through regions, and through accounts if you are an AWS organization. But you can do a lot better than that. First of all, get used to tag everything you deploy. You can enable cost allocation tags in the billing dashboard and have AWS track the cost of your tagged resources. Say, for example, you are managing 3 or 4 environments. You're managing dev, you're managing test, you're managing pre-prod, and you're managing the production environment. And it's not only about what is the revenue of the business because of the production environment, but also how much does it cost me to have dev, test, and pre-prod up and running so my team can develop and keep delivering value. So by tagging the resources, you can track the cost of each one of your environments by service, by environment, and all that is possible because of tags. Okay, if you already have an infrastructure as a code strategy, you can add that to your Terraform or CloudFormation code. And if not, well, we have been there, and it's a little it's a little how do you say it? I don't want to say annoying, but you can go resource by resource and adding small amount of tags that will be able to help you make better decisions. Again, not to talk bad about the billing dashboard, but we have Cost Explorer. We have this amazing tool that that gives us the ability to filter our cost and to show our cost in a more how do you say it, detailed way. You can create a filter by region, by service, group by region, service, availability zone, type of purchase, etc. And you can have your own reports set up so you can enter and create and see the information you actually need to see. It's really important to take a look at it. I think you need to enable it if you don't have it enabled. But once you do, you can get a more detailed picture on how are you spending money on AWS. And just for visibility, you can set up budgets for whatever you need in control. Basically, you can set budgets to let you know when you're spending when your resources are underutilized or overutilized, or you can create alerts to see if you are 80% on the budget you have for your development environment, for example. It's really useful to have some alerts and some budgets set up if you really need to track control on how are you spending money. And other than visibility, it's important once you have everything set up and everything and everything visible, you will be able to assess your current setup with asking you questions like, are your resources effectively used? Another important thing that we see a lot is that public traffic is billable traffic. Use endpoints for global services like S3, like Dynamo. If you're using the default endpoints, you're going to the internet, and AWS is charging you for that. You have the ability to create VPC endpoints to talk privately to those services. And of course, as you have seen before in the previous presentation, you can evaluate purchase option not only on EC2 on instances, but you have now savings plans where you can have compute and apply it to ECS, to AKS, to many other services where you can optimize the way you use your application. John, I see you there. I'm running out of time.
Yeah, that's all right. I actually gave you a little bit extra because I know the number of cohorts there are. I did not want to say
Mike, John.
I don't think we can listen very well to you're very in the background.
You know,
I tell you, upgraded. Thank you. And I was keeping an eye on it. Thank you so much. I apologize for any of that. What happens is it's actually switching over to my local mic instead of my podcaster here, and it's doing it automatically. So I've got maybe Gideon's doing some magic on my laptop. I don't know. Maybe switching it on purpose. So you know what, Nicholas, I didn't want to interrupt you. I know there are 5 pillars to talk about. So we kind of got to that one. I really want to ask you a couple questions.
Sure, go ahead.
So these two kind of piggyback each other. What does a well-architected remediation look like?
Oh, okay. So basically, the remediation is the next step to the review. The first step is to review the architecture, which is a 2 to 4 hours meeting to review the workload and assess everything we can on that. And then we, as consulting partners, we came up with a roadmap using, of course, the well-architected tool and adding our recommendations to that. You get assessed by a AWS solutions architect, and then you create a roadmap to mitigate all the risks that arise from the well-architected tool. These risks also come from with the assessment with possible solutions, and we create this roadmap where we as consulting partners implement those improvements for you with your team. I mean, with our customers' team to make your architecture better.
Nice. And just to kind of go off of that one, what is it like to be in the process of being well architected?
Well, it actually looks like it goes like as follows. We make a review. We take half a day maybe with you, and we like to say that we became your shrinks on architecture, because we ask you everything there is to know about your architecture, and we need you to be honest. Usually customers doesn't have to outsell what they did. They really acknowledge what they're doing wrong. Again, we create 2 deliverables. We give our customers the AWS well-architected tool report, and we have a separate report that we as consulting partners makes as recommendations. And if it's everything okay, we kick off the remediation. That is the process of mitigating all of these resources. The well-architected program has actually a perk that if you get to mitigate 25% of the risks that arise, the high risks that arise in your review, you get $5,000 credits in your AWS console because of your well-architected participation.
Yeah, that's to kind of offset the cost of doing some of the review and everything and the remediation that they try to do, correct?
Right, exactly.